Dear student, Assalamu alaikum. I am Dr. Muhammad Yusuf Swati from the Department of Chemistry, Salmia College, Peshawar. I am here in Swat and the weather is too much cold. So let's enjoy and warm ourselves with chemistry. Today, the topic which we will discuss is ideal gas equation. This lecture will cover two things today. One is the derivation of the ideal gas equation. That is, the first point which we will cover is the derivation of the ideal gas equation. You are already familiar that we have three variables of gases, that is volume, temperature and pressure. These are the three variables of gases, and all these three variables of gases, that is volume, temperature and pressure, they can be combined into a single equation, and that equation will be termed as ideal gas equation. So, in order to derive this equation, you are already familiar with Chas's law. According to Chas's law, you say that the volume of a given mass of a gas is directly proportional to the absolute temperature. But here we have to keep the pressure of the gas as constant. Similarly, from Boyle's law, you know that the volume of a given mass of a gas is inversely proportional to the pressure of the gas, but here temperature should be kept constant. And in the same way, from Avogadro law, we know that the volume of a given mass of a gas is directly proportional to the number of mole of the gas, that is N. Here P and T are constant. So these are the three laws which correlate volume with temperature, volume with pressure and volume with the number of moles of the gas. So if we combine equation number 1, equation number 2 and 3 into a single equation, then we can say that V is directly proportional to N, V is also directly proportional to T, but here in this equation, V is inversely proportional to P. So in this equation, we have combined all the three variables together. Or rearranging this equation, P is shifted on this side, so PV is directly proportional to T. If we convert proportionality sign into equality sign, then PV is equal to nRT. This equation which we have derived, that is equation number 4, that is termed as ideal gas equation. The equation which we have derived, that is PV is equal to nRT, that is called the ideal gas equation. Or if we rearrange this equation and shift this T on this side, then PV divided by NT is equal to R, where this R is ideal gas constant. Ideal gas constant. What is this ideal gas constant? We will discuss inshallah in the application. This equation PV divided by T is equal to R, and that is constant. So if we change the pressure from P1 to P2 and V1 from V2, T1 from T2, for 1 mole of a gas, let me say N is equal to 1 mole, because under standard condition N must be taken as 1 mole. So P1 V1 divided by T1 is equal to P2 V2 divided by T2. This equation is the more general form of ideal gas equation, right? So this is what we call as general gas equation. Stop.